in the soil health systems and how phosphorus stratification impacts phosphorus losses as well as water quality risks. They're going to present some data from a statewide survey that they have exploring phosphorus stratification. I can see your slides, Kelsey, and once I can hear you, I will drop off.
Awesome. Thanks so much for having us here today on the Badger Crop Connect. My name is Kelsey Hyland, and I'm an agriculture water quality outreach specialist in Northwest Wisconsin. And I'll be presenting today with my colleague, Laura Paletta, who is also an outreach specialist in Northeast Wisconsin. So today we're going to be presenting on the zone of interaction, exploring some phosphorus stratification. We'll be bringing in some statewide insights from the Discovery Farms program, as well as kind of a local on-the-ground survey we did with farmers across the state. So just to begin, if I can get my cursor. So just to give a quick outline of what we'll be talking about today, I will begin with a program introduction because the Ag Water program is a pretty new program within UW Extension. We'll start out with a quick primer of phosphorus losses in agricultural landscapes before diving into some Discovery Farms phosphorus insights that really inspired a statewide phosphorus stratification survey. Laura will talk about the survey, including the methods, results, recommendations, and plans for moving forward. And then we'll wrap up with some final takeaways and questions if anybody has them. So just to start, the Agriculture Water Quality Program is a newer program in Extension, and we deliver educational content for farmers, crop advisors, and conservation professionals on the relationship between ag production practices and water quality outcomes. And as you'll see later in this presentation, this relationship is often very complicated. And we work really closely with the Discovery Farms program, which is nested in the larger Ag Water program. So Discovery Farms has been around for a lot longer, and they are a farmer-led research program that has been conducting water quality research on real working farms for over 20 years. And because of their longevity in Wisconsin, we have this really rich water quality database that's super relevant to our Wisconsin farmers. So we're very grateful for this partnership and being able to work closely with Discovery Farms. So just a quick primer on how phosphorus moves off of agricultural landscapes before we start talking about some of the data. So phosphorus really moves off of agricultural landscapes in two ways. There's the one we typically think about, this particulate phosphorus piece. And particulate phosphorus is the phosphorus that's bound to soil particles. So when you have soil moving off the field, you have that particulate phosphorus moving with it. And I think this is the one most people are pretty familiar with. We've been talking about it for a long time, and we have pretty good ways to control it too, which is good news. The one we don't talk about as much is this dissolved phosphorus piece. So as the name suggests, this is the portion of phosphorus that's dissolved in water. And so theoretically, you could have clear runoff moving off of your fields, but you could have phosphorus dissolved in it. And this type of phosphorus too is often very bioavailable, the kind that algae really likes. So definitely a water quality concern that contributes to total phosphorus loading. So now to dive into some of our Discovery Farms data, some insights they've learned from their row crop sites for the past 20 years of monitoring across the state. So this graph on the left here is looking at annual particulate phosphorus losses in pounds per acre. So again, that phosphorus that's attached to soil particles. And comparing those losses in tillage sites versus no tillage sites or rotational sites, which is often some of our alfalfa systems. And what you can see here is that the particulate phosphorus losses are much lower in the no tillage group, about 2 to 3 times lower in comparison to some of those tillage sites. So from this data and from a lot of data kind of across the country, we know that no tillage is a really effective practice at controlling our soil loss and ultimately our particulate phosphorus losses as well. But the story gets a little bit more complicated when we start to think about our dissolved phosphorus losses. So this is the same graph, but the vertical axis is now looking at annual dissolved phosphorus losses in pounds per acre. And what you can see when we compare our tillage sites with our no tillage sites, we don't see a whole lot of difference. Did you want to unmute, Chris? Sorry, in our no tillage versus our tillage sites, we tend to see not a big difference. And if anything, we have some elevated losses in our no tillage sites. So if we dive into that a little bit more to kind of understand why we might see some elevated dissolved phosphorus losses contributing to similar total P loading, a big contributor is winter manure applications on frozen soils. So this is the same graph we were looking at before, annual dissolved phosphorus losses on the vertical axis. I just zoomed in the axis a little bit more so we can dive into the data. So a lot of our highly elevated points in that no tillage category when we're losing 5 pounds of phosphorus are a result of winter manure applications on frozen soils. So we know that this is a really important piece when we start to think about phosphorus loss reduction strategies in combination with our no-till systems. But ultimately, we do still see some elevated dissolved phosphorus losses in our no tillage sites. So trying to understand further why we might be seeing this. So one of the reasons we might be seeing some of those elevated losses is a trade-off of our no-till systems is that fertility is surface applied. And so that fertility can be coming from manure or synthetic fertility. And when it's surface applied, this is happening in the risky zone of interaction. So the zone of interaction refers to the portion of the soil that's most likely to be interacting with runoff, whether that's coming from snowmelt or rainfall. And especially in the case of Wisconsin, where a large portion of our year we have frozen soils. So that soil might be staying in place and not moving. But if we have a highly enriched surface soil phosphorus, that can then dissolve in that runoff water and be lost. So on this graph here too, or graphic, I have 0 to 1 inches and 0 to 2 inches labeled. Often the zone of interaction or the portion of the soil that water is interacting with can be even shallower, but we tend to see these dimensions in a lot of our research, and we decided to use these as well in our statewide survey, just because logistically they're a little bit easier to soil sample with a probe. And this relationship is also further supported by some Discovery Farms data. So this graph here is looking at study period mean surface soil test phosphorus. So this includes 0 to 1 inches and 0 to 2 inches, depending on the year that it was sampled. And we'll talk a little bit more about what soil test phosphorus actually is on the next slide, but ultimately it's an index of plant available phosphorus. And then on the vertical axis, we have dissolved phosphorus flow weighted mean concentration. So this is a way to control for flow. A kind of easy way to think about it is for every gallon of water that's moving off of an ag field, how much phosphorus is dissolved in that. And what you can see is that as that surface soil test phosphorus number increases, our dissolved phosphorus concentrations also increase. And we start to see a bit of a more dramatic increase at this 80 parts per million. And I will say this 80 parts per million is ultimately an arbitrary number. We know that the dissolved phosphorus risk goes up as surface soil test risk goes up. We decided to put a number on it kind of strictly for outreach purposes as a way to help farmers identify and prioritize fields first for phosphorus reduction practices. I'll also draw your attention to some of those orange triangles we see at the bottom of the screen. So those come from potato sites in Antigo, and despite having high surface soil test phosphorus, we don't see those elevated dissolved phosphorus concentrations. So they were not included in the trend line. And the reason we might be seeing not the same trend we see in our other sites is because potato systems are often managed at a lower pH, which can impact phosphorus availability and runoff dynamics. But I think there's a whole lot more on those potato sites. So if you're particularly interested in that, please reach out to us and we'll get you connected with the Discovery Farms data specialist who can speak a bit more on why we might not see the same trend in those sites. So now to talk a little bit more about soil test phosphorus, because I think there's a lot of misconceptions about this. So soil test phosphorus is not a measure of total phosphorus in the soil, which can be thousands or tens of thousands of pounds. But ultimately, a farmer is not going to care about all that phosphorus if their plants are unable to use it. So rather, soil test phosphorus, and the one we typically use here in Wisconsin is BRAE1, is an index of plant available phosphorus, or phosphorus that is likely to become available during the growing season because it's kind of lightly bound to that soil. And ultimately, this is correlated to crop response. So when a farmer goes out and takes their soil sample, they'll get their results back and they'll get put into a category from very low, which is less than 10 parts per million, all the way up to excessively high, greater than 30 parts per million. And then where recommendations are really striving for between the 16 and 20 parts per million. And I do want to put the caveat, this comes from A2809 UW recommendations. And this is for demand level crops on loamy soil, so corn and soy. So these numbers can change a little bit depending on the crop and the soil type, but I just chose to stick with one number to simplify this slide, but definitely check out those recommendations if your system is a little bit different. But ultimately, when farmers get their soil tests back, they get put into one of these categories. And if you're in that very low category, there's greater than a 90% chance of a yield increase with added phosphorus. So this is where it's recommended to build up P by adding synthetic fertilizer or manure, because the crop is really going to benefit from that phosphorus because there's not enough in the system. In comparison to excessively high, where there's less than a 2% chance of any yield increase with added P. So this is where it's recommended to draw down P, harvesting those crops while not adding any additional fertilizer. Because we know there's not going to be any yields benefit, and if we continue to build up that phosphorus, we can create a bank that's then vulnerable when runoff conditions arise. And if you remember that number from the last slide, that 80 parts per million, that's kind of far above this 30 parts per million. So not yield limited in any way, but a way we can start to make some water quality progress potentially. And so recommendations are really striving for this optimum category where the phosphorus added is approximately equal to the phosphorus removed in our crops. So this way we're not yield limiting our crops at all, but we're also not creating this bank of phosphorus that can be lost with runoff. So for example, this is just a hypothetical example. If a farmer went out here in Wisconsin, you typically take soil samples down to 0 to 6 inches. And if a farmer had field A and field B and submitted their 0 to 6 inch sample, it would come back as 30 parts per million. But this really obscures the fact that field A would have a much higher risk for water quality because most of this phosphorus is concentrated at the soil surface. So the same soil test phosphorus, but a different risk to water quality. So based on our Discovery Farms insights in this example, we were really curious about what this actually looked like on Wisconsin farm fields, which really inspired the statewide survey that Laura is going to be talking about. But ultimately, our Discovery Farms data shows us that no-till is a really effective practice for controlling soil loss. And what we know from our Wisconsin data is that farmers are doing an exceptional job with their no-till adoption, really doing a good job of protecting this soil. So we wanted to ask, what is the next step on the path to conservation, and how do we start to move the water quality needle a little bit further and kind of push some of these trade-offs we're seeing in our no-till systems where that fertility is surface applied, and how do we start to balance those? So that's really what inspired this local soil sampling project, and I will hand it off to Laura to share the results on that.
Great, thanks, Kelsey. Again, my name is Laura Paletta. I'm an outreach specialist with the Ag Water Quality team. Excited to share some of our project, our survey, why we did it. Kelsey shared and led us to this point of we know that there could be some stratification. We want to see what it's like in the state of Wisconsin. Is it something we need to worry about? Is it where might it be in the state? So Kelsey, you can go to the next slide. Thanks. So here is the map here shows where we ended up sampling. So we wanted to see the entire state of Wisconsin, what's out there. So we set out to just really take a survey and sample a little bit everywhere, looking at that question of, is phosphorus concentrated at the surface? We did want to prioritize some no-till fields, as Kelsey just shared. With no tillage, if you're not mixing up the soil, then you might have a concentrated level at the top. So when we reached out to farmers, we asked them to choose 2 to 3 fields, at least trying to have at least one no-till field, and choosing fields that had different management strategies. We also wanted to see if we could find what management might increase or decrease this stratification, and ultimately try to identify fields that had the highest water quality risk. So we ended up with a data set of 224 fields, and the pictures Kelsey shared there. I'm going to go back there, Kelsey. Oh. Perfect. We went out and our team sampled we sampled ourselves. So we were the ones to go out. This was a free service to the farmers, no cost to them. And it was a great outreach tool for us to chat with the farmers, explain what we're looking for, what that might mean. So a really great outreach for us to make those connections. We also were able, when we got the results back, to create a nice handout back to them, this individual report to share their results, and then dive a little deeper into each field, what we might recommend depending on those soil test levels. So now, the fun part, I would love to share some results on what we found. So again, this was 2 years of data, 224 different fields. Here we're looking at 0 to 2 inches on top versus we decided to share it as 0 to 6 compared to 2 to 6. Just in the ag world, I think we're all kind of used to that 0 to 6 sample depth. And then those recommendation levels on the bottom there. In red, I did want to point out that's that water quality concern, that 80 part per million or higher, as Kelsey explained. We wanted to put kind of a number to that water quality risk. And looking at that Discovery Farms data, above 80 seems to have that more dissolved phosphorus losses. So overall, what we see, there is a lot of phosphorus in Wisconsin. It does tend to be a little bit more concentrated and on the surface, that 0 to 2 inch level. And about 3/4 of that shallow depth were in the excessively high category. So 3 out of 4 fields at that shallow depth were higher than 30 part per million. And at that shallow depth, about 1/4 of the fields were in that elevated water quality risk category above the 80 part per million. So this was, again, a great tool for us to kind of see which fields are the highest and start there. That's a great starting point, kind of the lowest hanging fruit in that high category. And that's where we could tell farmers, start there, start with those fields, start some drawdown strategies at those fields. And some ways to do that. So here's some specific recommendations we can give some farmers. So one is to just stop phosphorus applications. If you can, just stop adding phosphorus. As Kelsey shared, there's a less than 2% chance of that yield increase if you're in that excessively high category. So it's a way to save some money without having any yield loss. A little bit more specific too, you could stop adding P in your starter fertilizer if you do starter. There is some mixed yield and economic benefit data out there. So some research shows that starter can give a little bit of a boost to yield, but it's unsure if it's because of the phosphorus or if it's because of other nutrients that's in the starter. So we talked to farmers about having each farmer play around with taking P out of their starter, maybe do some test strips to see if they see any differences. Another recommendation is to harvest cover crops. If you grow a cover crop, instead of terminating in field, completely harvest them, remove that phosphorus, remove the crop from the system. If you have manure in the system, if you need to apply manure in those higher level fields, it's important to avoid applying on frozen soil. When soil is frozen, it kind of acts like concrete and infiltration is greatly reduced. During the growing season, if you can, consider applying your manure below the surface, so getting it out of that risky zone while also minimizing soil disturbance. So a great tool to use is low disturbance manure injection. Again, just trying to minimize your soil loss so you don't want to disturb the surface, but if you can get that phosphorus out of the risky zone. Overall, it's important to commit long-term. Soil test phosphorus drawdown is a slow process. The stat here says in a typical corn crop, it removes about 3 to 5 part per million a year of soil test phosphorus. So you can imagine in a field, if you're over that 80 part per million, it would take quite a long time to get back to optimum range. So it's important to commit, take some of these recommendations, one or more, and implement them long term. I did want to give a little taste of other ways we're playing around with the data set. So we're extremely fortunate to have a big data set now. So we wanted to try to tease out some themes or some of those field managements that might play a role with having that higher amounts in the shallow depth. So here we're looking at a shallow depth of 0 to 2 inch samples. And part of in the information, the field management information we got from each farmer, we asked the question, have you added manure in the last 5 years? Now, I know this is very broad, but you can imagine in 224 fields, management was very different, manure was very different. So we had to keep it kind of broad in these questions. So you can see here, if there was no manure in the system, on average, soil test phosphorus was about 20 part per million less than if there was manure in the system. So this is a great tool, again, as outreach specialists, when we're talking with farmers, if they do have manure in the system, we could just tell them to keep a closer eye on those fields, test for soil test phosphorus maybe more often, or just keep a closer eye. Maybe it is worth them sampling the shallow soil depth to see what's really going on. So lastly, to kind of bring it all together, some outcomes. This was more of a survey, we like to call it, rather than more of the research. We still have a great data set we can play around with, but this was intended as an outreach project. It was great to be able to chat with the farmers, talk to them about stratification, really just to have that conversational piece. So there's some quotes that are on this slide here that show just kind of some great, in the end, how farmers liked to participate with this. I personally had a great success story with a farmer who he did see a higher soil test phosphorus levels on 2 of his fields. And so he went back to his co-op, talked to them. He was able to he took out the phosphorus in his starter. So he was excited. He saved some money that way, and he was hopeful to have a water quality impact as well. So it's kind of some stories like that each outreach specialists were able to experience, which is always fun. Okay, final takeaways. So just kind of taking a step back, thinking of phosphorus and water quality and how they go hand in hand. The first step to really reduce our phosphorus impacts on water quality is to control soil loss, keeping that soil where it is on the field. No-till is a great practice to do this, so it is an effective way to reduce our soil loss. However, we see that because we're not mixing the soil profile, P can become more concentrated at those shallow depths, and this is where stratification can play a role. And as Kelsey showed us, this can cause a water quality risk. Now, soil test phosphorus is just one risk factor when thinking about water quality risk. However, it is a risk factor we can impact. Those drawdown strategies I mentioned, those recommendations, we have the potential to reduce that soil test phosphorus and then reduce our water quality risk compared to other factors that we can't really impact too much, like slope or soil texture or topography, things like that. So hopeful that if we can use those drawdown strategies and reduce our soil test phosphorus, we can have a impact on our water quality. With that, I'd like to thank you, share our contact information. I see that Sam also put it in the chat. And if there's any questions, we'd love to take them, and I'll pass it back to Chris Clark.
Yeah, great presentation, and really liked the insight that both of you shared, and glad to have the Ag Water Quality team as part of the state's extension outreach team out there. Again, if you have a question, feel free to unmute, or you can drop that in the chat. I know both Laura and Kelsey will be on the rest of the webinar, so that they can answer that now, or shoot them an email at any time. They're both really experts in this project. Thank you again.